Alright, welcome, and now we're going to start mathematical modeling involving cosine and sine functions. Okay, so in mathematical modeling, what we're going to do is we're given data and we want to find the best model that fits the data. Now, in this case, since we're studying sine and cosine, obviously we're going to use those functions to describe what's going on. So here we've got this data set. We've got t equals time in hours, right? And y, which is depth, is recorded in feet. And so what this represents, this data represents the depth of the water at the end of a dock every 2 hours from midnight to noon. Okay, so where t equals 0, 0 corresponds to midnight. Okay, so now what we want to do is we want to use a trigonometric function to model the data. Okay, and then we're going to use that information, that model, once we come up with the model, we're going to use that information to answer a question. Okay, so the first thing we want to do is graph the data. Okay, so if we graph the data, let's do this. And again, I'll do my best. Okay, so there's my depth, and that's in feet, and then we've got time, right? We'll do that over here. Again, it's not going to be perfect. Okay, and so at t equals 0, we're at about 3.4, so we're right about here maybe. And then at 2, 8.7, 8.7 is maybe right about here. And then 4 is 11.3. And then 6 is 9.1. Eight is 3.8. And 10 is 0.1. And then 1.2 is at 12, so 1.2, let's say about right there. Okay, so we have something that obviously looks like a cyclic function. Okay, now the cosine function completes 1/2 a cycle between the times at which the maximum and minimum point depths occur. Okay. Now, we could use either a sine or a cosine model, right? So the cosine model, right, would have y equals a cosine bt minus C plus D, right? The difference between the maximum value and the minimum value is twice the amplitude. Right, remember that. So the maximum value is where? Is 11.3. Which I kind of miss. Yeah, this should be up here. Oops. Yeah, let me redo that. Like so. Okay, so 11.3, and the minimum point was 0.1. So basically 1 or 0, but 0.1. So 11.3, between 11.3 and 0.1. So that is going to be a range of 11.2. So half of that would be the amplitude, right? The amplitude then would be 1/2 of the difference between those two. So it'll be 11.3 minus 0.1. So that's going to be 11.2. So that's going to be 5.6, right? So the amplitude is going to be 5.6. Okay, now let's look at the period. Remember a period, well, let's think about this. What we have is we have this point and the minimum and the maximum point, right? So what do we know about cosine? So the cosine function is going to travel, or is going to complete half of its cycle from the maximum point to the minimum point. So at the maximum point is at 4 hours. The minimum point happens at 10 hours. Okay? So that distance is what? It's 6. So that means it's made half its cycle in 6 hours. That means the period is going to be double that. So the period is going to be equal to 12 hours. Okay, so now we got the amplitude, we've got the period, and so now what about B, right? We got to figure out what B is. Well, we can use the fact that the period is equal to what? 2 pi over B. Well, this would imply that so 12 is equal to 2 pi over B, so we just solve for B, and that means B would be equal to what? 2 pi over 12, which means that it's going to be pi over 6. So B is equal to pi over 6. So good, we got A, we got B now. Oh, awesome. Okay, now, what else can we do? Well, we got, let's find out what C is. Okay, now, let's look at where the maximum depth occurs, right? So the maximum depth occurs at 4 hours after midnight. Okay, so you could think of this as a phase shift, right? Because normally cosine happens right here. But so there's a shift, right? The maximum value happens at 4 hours after midnight at t equals 0. So I would say, well, the end point, the left end point is going to start at 4. Okay, which also means that C over B, right? C divided by B, which is our phase shift, right? Equals 4. Well, if we know B is pi over 6, that implies that what? So C is going to equal 4 times pi over 6. Now, how did I get there? Just think. If I replace B with pi over 6, I have to multiply both sides to get rid of that pi over 6. So I multiply by pi over 6 on this side, and I get pi over 6 on this side. And so now I get C equals 4 times this, which ends up equaling what? It's going to be 2 pi over 3. Okay, now, the last thing we need is D, right? Well, how are we going to find D? Remember, D is the line that this oscillates among. So that's easy. All we have to do is find the mid-range of this, of the range, right? We have to find the middle of the range. So we know how to find the midpoint, right? The midpoint is you add the max and the min and divide by 2. So the maximum value is 11.3. So D is going to be equal to what? 1/2 times 11.3 plus 0.1, which equals 1/2 of 11.4, which equals 5.7. All right, so guess what? This is going to oscillate around the y equals 5.7 line. All right, so now we've got our values. Now again, this is mathematical modeling. We would estimate this, right? We've got that value. We would also estimate this, right? So we've got all the values A, B, C, and D. So now it's just a matter of writing our model. So based on this data, our model is going to be equal to 5.6. Okay, cosine of 0.524t minus 2.094 plus 5.7. And that's our model. Have a great day. Oh, actually, no, we're not done. I forgot. We have a question we have to answer. Okay, so the question we need to answer is this. So we've got our model. Now we're going to use this model to answer this question. The question is, where's my question? Hold on. Oh, here it is. A boat needs at least 10 feet of water to moor at the deck. A boat needs at least 10 feet of water to moor at the deck. Okay, now, the easiest thing to do to answer this question is put this in your calculator, right? And so what they want you to do is determine the times in the afternoon that the boat can safely dock. Okay, so we could use our graphic calculator easily and find the answer to this question. Okay, because all we have to do is have the line y equals 10, right? Because we know that 10, that's the minimum depth. So if we graph the, on the graphing calculator, if we graph the line y equals 10, along with graphing this function, then all we have to do is find the intersection points of where that graph intersects, and the graph, anywhere, the intervals where the graph is above that line, y equals 10, is where, when the boat can safely dock. Okay? And so when you do that, you should get any time from t equals 14.7 and t equals 17.3. Okay, and so that would correspond to approximately 2:42 p.m. So this would be oh wait, hold on a second. Yes, 2:42 p.m. and what is it, 5:18. 5:18 p.m. Actually, no, this is oh, in the afternoon. Okay, that's right. Okay. I was looking at the data here because this is from midnight. So they want to know in the afternoon. So that's a key thing that I missed. So they want to know what times in the afternoon it can be safely docked. So these would be the times in the afternoon. It's not the only times that it could be safely docked. Obviously, it can be docked in the morning, right? Between these two times in the early morning. Okay? Okay, that's it. Now we're finished.